Woo me! I sure am lucky to live during the age of the smartphone. In fact, computers have come a long way from taking up a whole room to add 5 plus 5 to being able to run a space mission from my smartphone. In fact, I'm sure we can all agree that computers will continue to progress by getting smaller and more powerful. However, this trend leads to very valid fears suggested by physicists and computer scientists that computers will get so small that electrons will have trouble flowing through circuitry. And this means no more computers. However, we can prevent this by finding a new way for computers to process and organize information. And I think the coolest and most future-proof way to do this is through quantum computing.
You see, our modern classical computer runs by processing sure-stated data structures called bits. All a quantum computer is a computer that processes the spin of particles or charges called qubits. These are data structures that adhere to the laws of quantum mechanics.
And how does this make quantum computers any more efficient than classical computers? Well, it's because of the concepts of superposition and entanglement that qubits adhere to.
I'm sure you remember the tale of Schrodinger's cat, about the cat that was forced into a box for a day with a bowl of milk and a bowl of lethal poison. Unless you checked the box, that cat was in a state of superposition, where it was dead and alive. The concept applies directly to qubits, meaning they can also be in a state of 1 and 0 and anything in between before we collapse them. Entanglement is the quantum phenomenon in which quantum states are linked, like when you have two different gloves in each box, but you don't know which one is which. But when you open the box to see the right glove, you know the left glove is in the other box. Again, qubits work the same way, with pairs entangling each other based on spin.
Qubits are able to store multiple bits of information due to superposition, and because qubits can work with each other due to entanglement, qubits working together would be able to store exponential amounts of data compared to what the same number of bits would be able to do. And due to this, quantum computers can calculate new higher prime numbers that encrypts data, help with big data functionality, and run simulations, like mapping the human genome.
And there are other barriers too, like producing an absolute zero environment for the computer to run in, and not to mention the power supply. And these are all problems that prevent quantum computers from being practical in modern day. However, that's okay, because quantum computing is still a theoretical technology. It's a solution to a problem that may affect us hundreds of years from now. But more importantly, it's an experiment to produce a computer operating on the laws and fundamentals of quantum mechanics.